Hello everyone, welcome to Equal To, and this is the 10th episode of our Polynomials playlist. And in the previous video we saw what factor theorem was, and we solved a couple of example questions checking whether a polynomial is a factor of another polynomial. Okay, and we also found the value of a constant variable k. Okay, so in this video we are going to learn a new technique called splitting the middle term method. Okay, with that also you can factorize a polynomial, and also we are just going to factorize this polynomial in this question. Example 8, factorize 6x squared plus 17x plus 5 by splitting the middle term method, which we will be learning now, and also by using factor theorem. Okay, so that is what we are going to cover in this video. So first let us do this with splitting the middle term method. Okay, so before explaining the method to you straight away, that might confuse you a little bit. So let us take this example and I'll explain splitting the middle term method with this particular example. Okay, so let me just rewrite the question here. 6x squared plus 17x plus 5. So this is the polynomial here. Okay, so this method can also be known as I method. Okay, so why are we calling it as I method? You'll see that now. I'm just going to draw an I here, and what you're going to do is you're going to multiply these two numbers, right? The coefficient of x squared and the constant term, you're going to multiply these two numbers. So in this case it's 6 and 5, right? 6 into 5 is 30, and you are going to write that here, and you are going to write this middle term. Let me just circle with. You are going to write this middle term to the bottom, right? 17 here. Now what you are going to do is you are going to use trial and error to find a pair of numbers that on multiplying would get you 30 and on adding would get you 17. Okay, so let us take this really slow. It's very simple method. So we are going to find two numbers a and b. Okay, and this should be of the form where a times b should be 30 and a plus b should be 17. Okay, we are going to find two numbers with this criteria, and you are going to do that by trial and error. Okay, so if you are going to find two numbers that are going to be when you multiply those two numbers, if you get 30, so those two numbers should be factors of 30, right? It's an obvious point. If product of two numbers gives you 30, those two numbers are obviously factors of 30. So let us just list out the factors of 30 first. Factors of 30 are 1, 2, 3, 5 and so on. It goes on, right? So these are factors of 30. Now if one and some number has to multiply up to 30, what would be that number? 1 times 30 gives you 30, right? If a were to be 1, b should be 30 then. That is only when you get 30 as the product. In that case, if you just sum a and b, that is 30 plus 1, it gives you 31, which is not 17, right? So this is not the right number. Okay, so you can eliminate that. Now we are going to repeat these steps. We are having 2. If a were to be 2, then what should be the value of b? B should be 15. Only if b were 15, 2 times 15 gives you 30. Okay, so the product comes to be fine, and 2 plus 15 gives you 17. So this fits our specifications perfectly, right? This fits our requirements. So the product of two numbers comes up to 30 and the sum of two numbers comes up to 17. So 2 and 15 can be those numbers. Okay, so we have come to that conclusion. 2 and 15 are two numbers that when multiplied gives you 30 and when added gives you 17. Okay, now what you are going to do is you are going to take these two numbers and you are going to use them to rewrite this polynomial. Okay, so what do I mean by that? I hope you are clear with how we found out these two numbers. This is just by trial and error. You're just going to draw an eye and you're going to multiply these two numbers. So the coefficient of x squared and the constant term, and write it here at the top, and the coefficient of x is going to go at the bottom, and you're going to find two numbers whose product is going to give you 30 and whose sum is going to give you 17, and 2 and 15 are two such numbers. Okay, now we are going to use that to rewrite this polynomial. So 6x squared plus 2x plus 15x plus 5. Can you observe what I have done here? I have just rewritten 17x as 2x plus 15x. I have just rewritten this 17 as 2x plus 15x because 2 plus 15 gives you 17. So technically this is right mathematically, right? There is nothing wrong here. You have just written 17 as 2x plus 15x. Okay, now what you are going to do is you are going to try to factorize these terms. Okay, so in the first two terms here, you can say 2x is available in both these terms. Okay, you can take this 2x commonly as a multiplier outside, so that gives you 3x, right? Because 2x multiplied by 3x gives you 6x squared. So when you take this 2x out of this 6x squared, it is remained with 3x plus 1, right? Because 2x taken from 2x leaves you with 1. Plus, in this two terms, you have 5 as the common multiplier. So you take 5 out, that gives you 3x plus 1. Now we have two terms. Earlier we had 5 terms, now we have 2 terms. And in these two terms, you can see that 3x plus 1 is commonly available. So you can take that out as multiplier. Okay, because 3x plus 1 is commonly available, you are taking it as a multiplier, and that leaves you with 2x plus 5. Okay, and that is the factorized answer to this question. 3x plus 1 into 2x plus 5. That is the answer to this question. Now, please wait, I'll explain it a bit more so you can understand it a bit better. Okay, now I think you might be confused with this step becoming this one, right? How did we take 3x plus 1 commonly as outside? Let me explain that with a simpler example. Let us say we have 2x plus 2y. Okay, this can also be written as 2 into x plus y, right? This is quite obvious. 2x plus 2y, it can also be written as 2 into x plus y. That is exactly what we have done here. Just assume this 3x plus 1 as y, right? This 3x plus 1 is common in both, which is similar to the 2 that we have here. So if you take this 3x plus 1 outside, it will leave you with 2x plus 5. Okay, exactly like this, right? Just like 2 is common in both these terms, we have 3x plus 1 common in both these terms. So when we take that out as multiplier, you will be left with the remaining terms, in this case x plus y, in this case 2x plus 5. Okay, so that is all. It's very simple. I hope you get it. Okay, so that is how you solve this question. You are just going to draw an eye here first, and you are going to write it in this form. You need 30 and 17, right? So that is the product of x squared, the product of coefficient of x squared, which is 6, and the constant that gives you 30, and the x coefficient is 17. So you are going to find two numbers whose product is going to be 30 and whose sum is going to be 17. Okay, with that, if you find a number, you are just going to use trial and error. You are going to put values into it and you are going to see if any value fits it. Okay, 2 and 15 are one such pair. So you are splitting the 17 as 2 and 15x, and with that you can just going to take the common factors out. In the first two terms, 2x is a common factor, so you are taking that out. So that leaves you with 3x plus 1. In the last two terms, you have 5 as a common factor. So when you take that out, you are left with 3x plus 1. And 3x plus 1 remains as a common factor in both these terms. When you take that out, you are left with 2x plus 1. 2x plus 5. Okay, so that gives you the answer 3x plus 1 and 2x plus 5. And that is the factorized form of this polynomial 6x squared plus 17x plus 5. Okay, now with that, we have solved the first method to solve this question, okay, which is by splitting the middle term. Okay, Now there is also another method that we are going to see, which is called factor theorem. We have already learned factor theorem in the previous video. We are going to use that to factorize this. Now that we'll see in the next video. So thank you so much for watching this video. If you have any questions in the method that we discussed now, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.